The parent function of a linear function is y equals x. The domain or x values is negative infinity to infinity, and the range or y values is also negative infinity to infinity. It has odd symmetry because it's reflected over the origin. Linear functions are not bounded because they continue in a straight line in both directions. There are no asymptotes in this graph because it's continuous at all x. This linear function is increasing from negative infinity to infinity and has no extrema, or minimum and max points. The end behavior of limit of f of x as it approaches infinity equals infinity, and the end behavior of limit of f of x as it approaches negative infinity is negative infinity.
This is a graph of a quadratic equation, or a quadratic function. The parent function is y equals x squared. The domain is negative infinity to infinity because the graph goes on forever across the x-axis. The range is 0 to infinity because the vertex is at 0. There are no values on the y-axis below 0, but they go on forever in positive values. The graph is evenly symmetric over the y-axis. The graph is bound below at x equals 0. There are no asymptotes because the graph is continuous. The graph decreases at infinity to 0 and increases from 0 to infinity. The graph has an extrema of an absolute minimum at 0 at x equals 0. The end behavior of limit of f of x as x approaches infinity is infinity. The end behavior of limit of f of x as x approaches negative infinity is negative infinity.
A cubic function has the parent function of f of x equals x cubed. The domain and range are both negative infinity, infinity. Cubic functions have odd symmetry and no boundedness, asymptotes, discontinuities, or extrema. It increases at negative infinity, infinity. The limit of x cubed as x approaches positive infinity is infinity. As x approaches negative infinity, the limit is negative infinity.
An inverse linear function, also called a reciprocal or rational function, has a parent function of f of x equals 1 over x. The domain and range are both negative infinity, 0, and 0, infinity. This function has odd symmetry and no boundness. The horizontal asymptote is at y equals 0 and vertical is at x equals 0.
This function has a non-removable infinite discontinuity at x equals 0. It also decreases at negative infinity 0 and 0 infinity. There is no extrema. The limit of 1 over x as x approaches infinity is 0. As x approaches negative infinity, the limit is also 0.
Our parent function of a square root function is f of x equals the square root of x, and the graph looks like this. It is bounded below, only increasing from 0 to infinity. It has a minimum of 0 at x equals 0. The domain and range of our function is 0 to infinity, and the end behavior of x as it approaches negative infinity does not exist, and the end behavior of x to infinity is infinity.
An exponential function x of x the graph looks like this. It is bounded below. The asymptote is y equals 0. It is increasing from negative infinity to infinity. The range is 0 to infinity. The domain is negative infinity to infinity. The endpoint is limit of x to negative infinity equals 0. The limit is x to infinity equals infinity. This graph is bounded below. It has an asymptote of y equals 0. It is decreasing from negative infinity to infinity. The domain is negative infinity to infinity. The range is 0 to infinity. The limit of x to negative infinity is infinity, and the limit of x to infinity is 0.
Logarithmic functions are inverse of exponential functions. This graph shows how the two functions translate over the y equals x line. The domain goes from 0, not including 0, to positive infinity. The range is from negative infinity to infinity. There is no symmetry. The boundedness is x is greater than 0 because there is an asymptote at x equals 0. There are no discontinuities. The function increases from 0 to infinity. And there's no extrema, and the end behavior is as shown.
The absolute value of a function, the domain is negative infinity, positive infinity. The range is including 0, infinity. The symmetry would be even. There are no asymptotes. The increase and decrease would be negative infinity to 0, and then 0 to positive infinity. The local minimum is 0, 0. It's bounded below. There are no discontinuities, and in behavior is limit f of x as x approaches infinity is positive infinity, and limit f of x as x approaches negative infinity is negative infinity.
This is parent function number 9, the greatest integer function.
There is no symmetry. It is not bound. There is no asymptotes. The discontinuity is jumping at every x value, which is removable. Constant on each step. There is no extrema and no positive or negative infinite end behavior. The domain is negative infinity to infinity, and the range is a set of all integers.
This is parent function 10, the logistics function.
There is no symmetry and there are no bounds. There are two horizontal asymptotes, the x-axis and the line y equals 1. There are no discontinuities and are no extrema. It is increasing from negative infinity to infinity. The domain is negative infinity to infinity, and the range is 0 to 1. The end behavior is limit of x to infinity equals 1, and the limit of x to negative infinity equals 0.
Another function is the sine function, which its parent function is y equals the sine of x. This is the graph.
The domain of the function is all real numbers, and the range is from -1 to 1.
The function is symmetric with respect to the origin, and therefore it's an odd function. The function is also bounded.
This function doesn't have any asymptotes, and it's a continuous function.
The function has an absolute maximum of 1 at x such that x equals pi over 2 plus 2 pi k, where k is an integer. The absolute minimum of 1 at x such that x equals 3 pi over 2 plus 2 pi k, where k is an integer.
For the end behavior, the limits do not exist. Also, the increasing and decreasing of this function oscillates between -1 and 1.
This function is the cosine function, which parent function is y equals cosine of x. There's the graph.
The domain of the function is all real numbers, and the range is from -1 to 1.
This function is symmetric with respect to the y-axis, and therefore it's an even function. The function is also bounded.
This function doesn't have any asymptotes, and it's a continuous function.
The function has an absolute maximum of 1 at x such that x equals 0 plus 2 pi k, where k is an integer. It has an absolute minimum of -1 at x such that x equals pi plus 2 pi k.
For the end behavior, the limits don't exist. Also, the increasing and decreasing of this function oscillates between -1 and 1.